Chapter 9 is about chemical bonding, the Lewis model. We're going to look at three different models of chemical bonding. These are theories. Theories, remember, explain. Laws state what happens. Theories explain why. This helps us to understand why some molecules are stable, others are not. They help us to understand the shapes of molecules. And shape is important because physical and chemical properties are somewhat dependent on shape. And each of these three theories is very useful, but none of them are perfect. And there's this trade-off between predictive power and complexity. So you can go with the one that explains things the best, but then it ends up being really, really complicated. Or you can go with the simple one, which is much easier for students especially to understand, but then it doesn't always work, doesn't predict things as well. So we're going to look at all three of them and understand that some of them are more useful in some situations than in others. Bonding theories are very practical. Back in 1989, the structure of HIV protease was determined, and I know some of you are more into biology and stuff like that than I am, but this is a protein that is synthesized by HIV. And one of the goals in stopping a virus like HIV is to find something that will disable the virus without killing the host, the person. And so they were able to find several different molecules that disabled the HIV protease by binding to its active site. And the bonding theories were helpful in this because instead of just randomly trying things, they were able to look at the active site and identify characteristics about it and then try molecules that had a much better chance of working. And so they were able to find some that worked. And these protease inhibitors don't cure HIV, but they reduce the viral levels often to undetectable levels. So the person is still HIV positive, but they're not going to have any symptoms. And in fact, a blood test may come up negative because the virus is so suppressed. Now, if they stop taking the medication, then the virus will rebound, and that'll be a problem. But still, this is a huge, huge thing. And it's made possible because of bonding theories. So the first one we're going to look at is the simplest one. It's called the Lewis model. It's named after an American chemist. We've heard a lot about European chemists, and here's an American. 1875 to 1946. In this model, which you may be familiar with, valence electrons are represented as dots. And so we draw what are called Lewis electron dot structures as pictures of molecules. Sometimes they're called Lewis structures, electron dot structures, all different combinations. So I'll try to be consistent, but it's not going to happen. This is the simplest model and allows us to give quick predictions about shapes and stability.